Yes. Thank you very much, Philip. Yes, we have the plan that we every month during the existing of this period, we present some important science going on in other regions of the world, where I know that there are also long-term thinking and plans and ambitions. And I'm very, very honored that Professor Hong Li will be our premier excellent speaker. I can't see anyone better because Professor Hong Li has a very long background in battery research. He has done important advances in many fields for high energy batteries, nanosilicon and anodes, which is still a very important topic in Europe, etc. And Professor Hong Li comes from Chinese Academy of Sciences, and he has also been able to do a lot of innovation. So maybe more than 100 patents, which is really impressive from a European standpoint. And what more is that Hong Li has a very broad overview of the research landscape or the global ideas on what kind of batteries we would foresee in the future, and have compared the different roadmaps when it comes to the next 5-10 years from Europe, US, China, and whatever. And it will be a pleasure really to listen to you now and hear your views on what's going on, and also learn a little bit more about China. I personally think that research and that is really a peace project where we speak the same language all over the world, irrespective of what country we are. So I'm really happy that you share your love for research for us. Thank you so much and welcome. I leave the floor to you.
Thank you. Thanks, Philip. Thanks, Christina, and really thanks, Professor Christina Estrom, to invite me to join this very important seminar. So actually, battery 2030 is a very important, I think, as mentioned just now, the largest scale research initiative and also long-term roadmap and action in battery research. This is very important to realize carbon neutral. So I think it's also a very hot topic and very important research direction in China. So today it's my pleasure to share some latest progresses of batteries and also our future roadmap and plan for next 5 years. So 3 parts in my talk: battery strategies and also R&D highlights and also future plan. Actually, China has decided to develop electric vehicles since 2008 officially. So we set the 3 steps. So in the last steps, we would like to construct a new structure and mainly develop the intelligent electric vehicle since 2020. So we expect in the year 2030, we could have 100 million vehicles, electric vehicles. So I think this is a big change for the transportation. And here we show our last 20 years, step by step. In the year 2001, we mainly studied the nickel hydride batteries and also lithium magnesium oxide power batteries. And in the year of 2006-2010, we mainly researched on the lithium iron phosphate, and later to study NMC power batteries. And also last year, we tried to develop high energy density batteries and with higher safety. And the cost has been successfully decreased significantly, less than 1 Chinese RMB per watt hour. And now it's only less than 0.1 US dollar per watt hours. And the pack density have reached 200 watt hour per kilogram now. So it can support 600 kilometer driving distance per charging. This is a last 20 years effort and the target. And in the year 5 years before, we have drawn these pictures to show the main national project in different directions, including the high energy density lithium-ion batteries, and the solid lithium batteries, lithium sulfur batteries, and the lithium air batteries, and also high energy density and high power lithium batteries for startup applications. This is a roadmap previously. And also for the energy, so we already announced in China this year. So in the year of 2030, we want to go to a carbon peak, and in 2060 go to carbon neutrality. In order to realize this, so the energy research direction, including the 7 part: coal, renewable energy, nuclear energy, smart grid, energy storage, hydrogen energy, and energy consumption. So this kind of direction is used for next 15 years. This is made by the National Mid-Long Period Strategic Committee in Energy. I'm the vice director for this committee. So the target is clean, low carbon emission, safe, and high conversion efficiency. And the main strategy is developing renewable energy, related energy storage technology, electric vehicle, and of course the high power batteries for EV and smart grid, and constructing a new electric power system composed of mainly renewable energy. That will be the main strategy. And so now I want to just highlight R&D on battery in China, mainly 2 parts: the lithium-ion battery and the new battery systems. So here I also show a production line and also the research line, the innovation chain you see here. So in China, actually from the raw material to the recycler, so already formed matured production chains, including every part of the material and also cell and module and pack and many different applications, and also the evaluation, sensing, safety, failure analysis. We want to enhance the innovation ability of this kind of production chain and innovation chain by introducing intelligent battery manufacturing techniques and smart sensor, big data analysis, artificial intelligence and digital twin technology, and also advanced test characterization and the failure analysis technology. So here is a summary. Just I used the Web of Science to make a count. Yesterday, you see, it's yesterday. So only use the keywords like lithium battery. Here is the publication in last year in the world. So here is China, and the second one is USA and South Korea, and also a lot of European countries here. Here is the institutions or organizations. The Chinese Academy of Science is ranked #1 in the world, and also some in the top 10, they are 8 from China. So that means the activities in China in lithium battery is very active. And another very hot topic is sodium batteries. Here is a summary you see. It's China, USA, and South Korea, and Australia, and Germany, India, and so on. And here is the organization. You see this diverse is much diverse compared to lithium batteries. So it means the research on sodium battery are quite just starting. So there are very few organizations can become very high ratios here. So with this information, just to show you that the activities in battery research are very strong and very active. So the publication in sodium already, you see, is a 2000. Just now, the lithium is 13,000 papers in the database of Web of Science. And now I want to just highlight some very important research I feel. So firstly, is the lithium-rich cathode for high energy density lithium battery. Lithium-rich cathode material has been proposed by Microcycria and Jeff in 2001. So however, there are still a lot of challenge like the voltage decay, cycle life, gas release. So after long-term research and optimization, we try to scale up to produce this material for develop high energy density lithium batteries and also high energy density of rechargeable lithium batteries. So here is the research from the CAS Institute. And also the high voltage lithium copper oxide is very important for consumer electronic devices applications. In last year, we have published a solid electrolyte coated LCO, which can deliver high capacity and reasonable cycle life. By protect the surface is very important to decrease the surface oxidation ability. This is very practical way and also already scaled up now. And for the silicon anode, so the research progress still continue. So after pre-lithiation of the material level, so the first Coulombic efficiency and capacity and the cycle life and also volume expansion can be controlled, and which can be used for the real batteries. This is very important. So to do the pre-lithiation for the material level. And also for the faster charging anode, this is very important. So the group from the Huazhong University, they developed the hard carbon nitrogen doped, and which has been used for the mobile phone. And this currently the mobile phone application need 5C to 6C charging rate. This is very important to change artificial graphite to hard carbon to get the high rate performance. And also the interface is a very important issues for lithium-ion batteries. But the understanding at molecular level is not so easy. So the research group in Suzhou University, they developed a new calculation method, so-called VCR and higher. So just to try to simulate the reduction of the chemical, electrochemical reduction and the electrochemical deposition processing. So try to understand the complicated ICI procedures. I noticed Battery 2013 project initiative also pay much attention on interface. So here I would like to also emphasize this is very important to guideline how to design the suitable combination of solvent and salt to get what you want, the composition and structure of ICI. So here is a summary how to ICI from the initial chemical reaction go to the electrochemical reaction and grow gradually step by step. So this progress is just can calculate long time scale. Previous is very difficult. Only based on new method, new calculation method is possible. And we hope in future we can have a good connection and also exchange with the European team just to improve the understanding on this very complicated issue. And this is very important for lithium-ion batteries. And also another group try to understand the interaction between salt and the solvent and try to use the machine learning to get the optimized electrolyte to used for lithium-ion battery and the lithium batteries from the Tsinghua University, Zhang Qiang's group. And another very interesting material is so-called traditional current collector. We use the copper foil and aluminum foil, but it's not so easy to pass the nail penetration, especially for high energy density cell. And recently, so the several research group and company investigate that if you can deposit copper or the aluminum on the surface of polymer substrate like PET, so the cell can have the can really easily pass the nail penetration, improve the safety. This kind of technology already commercialized this year in ATR, in Opal, and also in CATR and other companies. This is very interesting funding I would like to mention to you. And also for the for developing high density lithium batteries, so CATR is very good. Do very good job in batteries. So they already put the 300 watt-hour per kilogram cell into the electric vehicle applications and are already scaled up to produce from the cell to the modular and to pack and get a high pack energy density, which can support from 600 kilometer to 1,000 kilometer driving distance for different car. So for this kind of high energy density, mainly use the high nickel and also high capacity silicon graphite combination. The key issue is to try to solve the volume expansion issues and also safety. And here is the cycle life at 25 degrees C. And also they also develop a very interesting packing technology, so-called C2P, cell to pack, very high efficiency for the packaging. From the cell to pack, get 82 to 84%. This is very encouraging and to support the car for long driving distance for the limited volume, and already used in the European car also. And another issue is the safety. Safety is very important. Last year and this year, the research group in Tsinghua from the CES, Professor Cui, they noticed lithium hydrogen will accumulate in the lithium-ion batteries. This is very dangerous to cause the thermal runaway behavior. So their understanding of the formation of lithium hydride and how it goes from the former to the self-heating and thermal runaway, they get a very clear understanding and published in this year's paper. If you're interested, you can contact with them and also see the papers. And in order to improve the safety, definitely solid-state electrolyte used in battery will be very effective strategy. But this does not mean the application of the solid electrolyte can improve the safety and can get the intrinsic safe. So in our group, collaborated with Professor Yifei Mo from UMD, US. So we understand that LATP and LAGP will react with lithium at anode side to get a similarly thermal runaway. Of course, the T1 temperature is 200 degrees C and 300 degrees C, much higher than liquid one, but still you have the thermal runaway. But however, LT2 and L0 do not have thermal runaway behavior. So that means even for oxide electrolyte, so still some are more safe and some are not safe. So this should be carefully selected in future for the design the solid-state battery or hybrid solid liquid batteries. And also how to increase the safety issue when you use the high nickel or lithium-rich cathode. So the oxygen release is the key issue, but how to de-risk? So we notice with the addition of L0, so you can treat the oxygen release. You can also delithiate it from L0 to the delithiated LCO. And then surprised oxygen release. This is a new mechanism found recently, not published yet. So we feel with the addition of solid electrolyte, not only because not improve the safety, not only because decrease the liquid one, but also you can have the ion transport, ion exchange and the surprised oxygen release. This is very interesting and also very valuable funding. For the battery safety, they are very famous group in Tsinghua University, Professor Minggao Ouyang. So they have a very big research team to try to study battery safety since 2007. And already they get a database of different material. So how is the thermal runaway? What's the typical temperature, T1, T2, and T3? And for different systems, what happens? And then they get a database of this one. And also they already understand for the thermal runaway, 10 types thermal runaway behaviors. So what happens here? So each of the reaction and what happens at interface and in the bark. And also in order to understand the thermal runaway behavior from the cell to the pipe, so they already developed the 5th generation simulation method and the software. So now those kind of simulation and software have been used by several car companies, which can accurately simulate the thermal runaway behavior in any case. And also a sensor is a very important thing. So the research team in the Beijing Institute of Technology already developed the wireless sensors inside the cell. So including cylindric cell and also pouch cells and also the prismatic cell. So they can get the signal via the wireless method. So can get the internal temperature, internal voltage, internal gas, and internal strain. So now it's already demonstrated, and I think they would like to have a company to do this. This is one type of the embedded sensors inside the batteries. But as we know that the lithium-ion battery used liquid electrolyte, which could corrosion. So we have already set a new standard how to prevent the corrosion of the sensor inside the lithium batteries. And another, here is the summary of the internal temperature field sensors. Okay, and another team from the Huazhong University of Science and Technology, they developed the different gas sensors with array sensors. You can detect the different gas at the same time when you integrate it like this circuit. So now you can detect the hydrogen, oxygen, carbon monoxide, and carbon dioxide. It is already known. So before the smoking release, the hydrogen will appear 10 minutes early. So this is very important to have the hydrogen gas sensors in the cell, outside cell or inside the cell. And also how to detect the inside of the cells. So the research group in Huazhong University of Science and Technology, they have tried to develop the ultrasonic scanning technology, which now is very useful and very powerful, can detect electrolyte whiting and early gassing, and also lithium plating, and also SOC mapping. So this has already been produced and used in industry by many companies, and we also use this machine to detect the solid-state batteries, everything. So it's very interesting technology. And then now I want to introduce briefly about the new battery research. So the material for the solid-state battery is a very hot topic in China. But for the oxide electrolyte, we need to find a new oxide electrolyte materials. LLTP has a famous this year. So Professor Tang has reported a new material, so-called lecithin structure, lithium, zirconium, silicon, phosphate. So it has ionic conductivity at 3.5 millisiemens per centimeter in 20 degrees C. This is the highest ionic conductivity at room temperature for oxide electrolyte. And it has a very wide operation electrochemical windows, and it's stable in air and also stable against the lithium and cathode. And also it does not consist of rare earths. It's only consists of cheap elements like lithium, zirconium, silicon, phosphorus, and oxygen. So this is very promising new oxide electrolyte materials. And we are trying to develop the related science of the solid-state battery. And Professor Ma in University of Science and Technology of China, they has the very advanced TM, and they noticed some defect loops based on the very carefully TM observation. They are developing a new materials, so-called lithium zirconium chloride. This material is very interesting. This has very high ionic conductivity and much cheaper, and also it is a solution dissolver the electrolyte. So it's very useful for surface coating and also very useful for the in-situ solidification in the cells. So we feel this material is very promising compared to the sulfide. So here is the 811 cells with a very high rate performance and cycle life. Of course, sulfide is very attractive, but sulfide has a big challenge for the air sensitive. So the research group in our institute, Professor Fan Wu in Liyang, so he is trying hard to develop air stable sulfide materials. Here is the ionic conductivity and also some materials from this work. So it's already about 1 millisiemens per centimeter. So this is also attractive and promising for real applications. And here is the summary of the batteries. Use this kind of air stable sulfide electrolyte to get the cycle life and high energy density. And for the anode side, there are a lot of possibilities. Today, I just showed lithium alloy. So because this can be easily fabricated by roll-to-roll technology. So the research group from the Tongji University, they do this job. which is quite practical and can be scaled up. And another research group from Tsinghua University, they also used similarly like pre-lithiation, just print the carbon fluoride powder slurry on the surface of lithium to get a mixed ionic conductor surface coating, just to counter the lithium plating formation. So, and also they also check the interface of the solid state battery. I will skip these details. And in the Institute of Physics, we have already proposed so-called in-situ solidification, because the main challenge in the solid state battery is how to keep atomic level contact between the electrolyte and the electrode. So we feel only in-situ solidification can solve this problem. So we convert new design, the liquid electrolyte, into the solid partially or totally. If it's totally, it's all solid state batteries. So the anode and cathode can be selected anywhere. So this is the main concept. And with this concept, we can use the available machine except pre-lithiation and also the in-situ solidification. So the rest of them are similarly. So we can fabricate batteries with high energy density and long cycle life, low temperature performance, and high rate performance. And with this technology, we already fabricated this cell for the joint application. Last year, we have sailed out already. And this year, we already developed the cell level 350 watt-hour per kilogram. So with this cell technology, end of next year, we will produce the 2 gigawatt-hours high energy density lithium hybrid solid liquid lithium batteries for 1,000 kilometer electric vehicle used for the NIO's ET7 car. So which has high energy density, safety, and the long driving distance and the fast charging performance. And also, because we already know how to do pre-lithiation, it's possible in future that cathode does not contain lithium. So we have collaborated, and Professor Wang, they have proposed to study iron sulfide cells. And here you see these cells can deliver 390 watt-hour per kilogram. So this material is very cheap and can get the cycle life. So we are very happy because in the early year of the lithium batteries, so people already proposed iron sulfide 2. Okay, and also
2 minutes.
Okay, thank you for reminding me. Yeah. Also, another group in Nanjing, they proposed the sealed lithium oxide batteries, which you can, if you are interested, you can see the paper in JAR last year. And also like the new salt-involved low concentration cells, which just want to extend electrochemical windows. And okay. And another last issue is the sodium-ion battery. Professor Yongsheng Hu in our research group, they have developed the cathode material and anode material, and also know how to control the structure. And here is the anode for the 400 milliamps per gram. And now sodium-ion battery already delivered the comparable performance like lithium iron phosphate with low BOM cost. So it's very interesting, could be used for many applications. This already demonstrated for the car, bicycle, and energy storage. Okay, finally, I want to introduce the national project briefly. So here, just the Professor Christina mentioned, we have drawn this slide. We want to increase energy density by different roadmap. And here is a summary. If you are interested, we can discuss later after this meeting. So we already set up the new materials and also new battery technology, including solid battery, dry coating, and the CTP and the smart sensors, for example, here. And the target is try to decrease the cost of the cell and also extend the service life, cycle life, and also for energy storage, scale up the station scale to 1 gigawatt-hour per station, and become more smart and intelligent. And in China, the national project is diverse, not like I really appreciate the battery 2030, one project dealing with everything. So in China, the battery project dispersed in the material type project, an energy related project, and also some supporting project. And also in the each program will support 40 to 60 projects, each project roughly $1 to 20 million US, and also the research project cover R&D in production and innovation. In the year of 2021, especially, solid battery is a hot topic in the material, in the energy, and in supporting. Both of them support different research. And so here, the final slide is the roadmap. For us, we want to decrease the cost and increase energy density, and more practically. So we believe the lithium-ion battery step by step is a practical way, and the increased energy density of lithium-iron phosphate and the lithium spinner is a very promising direction, and also sodium-ion battery for energy storage. But exception is it seems that the lithium sulfur and transition sulfide could increase the cycle life in near futures. So that's our roadmap. Sorry to occupy too many times. Thanks a lot of people from our institute and from many university, institute, and organization. Thank you for your attention. Collaborations are welcome.
Professor Li, this is indeed the most impressive overview of what's going on in China, and of course with such a big country, it really is impressive. And I have some questions in the Q&A, and I have a question also in the chat. I don't know if you could allow us the time that you write the answers, because we have a little bit of limited time, so we need now to go into how the business part looks. So thank you so much. We are really highly appreciate what you have shown us, and we hope to reach out for good collaborations in the future with you. So I now hand over to Philippe Jacques to move on.
Thank you, Christina.